Hey guys, Mr. Enyart here. This is grade 6, module 4, lesson 30, first one in whatever comes after GH, topic H. So got a lot of explanation, went over a few pages on this one to kind of make it all tie together, but hopefully it helps. Here we go. So here we are on lesson 30, grade 6, module 4 of Engage New York Eureka Math. So we are looking at some terms that they want us to draw and write a description. So here they are. You can screenshot this, write this in your notes. But things to know, acute are angles that are less than 90 degrees. So you'll see like this. And if I zoom in, you can see I've got the little angle shown right there. Real small like, but I'm able to zoom in. Obtuse is greater than 90. Right is exactly 90, which is like a perfect L. So in a square or a rectangle. And straight is literally just a line, a straight line. And one thing to note about straight is that they are 180 degrees, which is the combination of all angles in a triangle. When unfolded, they make a straight line. But 180 degrees is a straight line or a complete turnaround from opposite directions. And a reflex is an angle that is greater than 180 degrees. I think of it as the outside of the shape, right? The angles we usually look at are inside the shape. The reflex is the outside. So if you have a 90-degree angle, right, the outside angle is going to be 270 degrees because to get from one point to the other is 360. And you could think I'd have to go 90 here, then 90 here, then another 90 here. And so the reflex angle is the outside of a shape, or the opposite of the inside, and it's greater than 180 degrees. So how does that geometric information help you understanding that 90 degrees is a right angle, acute's less, and obtuse is more, and that a straight line makes 180? Well, because in questions like this, you can see we have a 90-degree angle from A, B to C, but then D intersects it somewhere right in here, and ABD is 57 degrees. So that is less than 90 degrees, but what we can see is that the relationship in these angles is that ABD plus DBC, which would be 57 degrees plus X degrees, should equal 90 degrees. So I could write something like 57 plus X equals 90, and then I can use my fact family, recognize that 90 is the total. That means I've got 57 and I've got an X. What can I do to find my X? The easiest way? That's right, subtract. I'm going to do 90 minus 57, and that will give me what X is worth. So that's why this information is useful. So X should equal 33 degrees. And in example 2, we've got an information here. You can read that, pause the video, and figure it out yourself. But remember, what we're looking at is the relationship between a 180-degree straight line, right? This line here is 180 degrees. So I could say a couple true things here, that y plus 115, right? If I do that, doesn't that go right along the straight line? So what does that have to equal? Okay, and then doesn't 115 and X also go right along that straight line? Yes, it does. So that's going to have to be, so X plus 115 has to equal 180, which kind of tells me, uh-oh, maybe X and Y are the exact same. In fact, pretty sure they are because they're opposite angles. So I don't know why they gave them the same name, because they're using it as a variable here, X degrees, Y degrees, so that would assume that X and Y are different amounts of degrees. Now if they had, an angle name here, like A, B as the dot to C on this line, and then this one was like C, B, D, or CBA, those are different angle names, I get that. But anyway, soapbox, whatever you want to call it. X and Y both have to equal the same amount, and they both have to be added to 115 to be 180, so I'm just going to do 180 minus 115, which is 5 there, 6. 65 degrees is what X and Y both equal, and that would solve her problem. All right, and here goes the problem set. So question 1, solving for x. We recognize, again, pause the video, do the work on your own first, check back with mine, right? That the angle that we're looking at from this line to this line, this little box means is 90, and that 90 has been split or cut, right? Intersected by another line, which created an angle that is less than 90, and so we know this is 52. So x plus 52 has to equal 90. Which means 90 minus 52 will equal x. So that means x equals 38 degrees. And all they did on this one was add another line that intersects. It is now going to be a three-step problem. 15 plus x plus 25 has to equal 90. So I'm going to combine the two numbers that I can, and that's going to be 40 plus x equals 90. And now I can just do 90 minus 40, and that will give me x. So therefore, x equals 50 degrees. Number 3 is a separate problem from 4, so this picture does not apply to this one. You're going to have to draw number 3. So he needs to determine the angles that should be cut on the tiles floor to fit a corner. Now the angles of the corner is 90 degrees, so we're going to make an, close to a perfect L. One piece is going to have to be 24 degrees. That's a pretty small angle. And we're going to write an equation to use it to determine the unknown angle, which we'll just call x. So the equation we could write would be that 24 plus x equals 90. And then we could do 90 minus 24 to equal x. And therefore, x equals 66 degrees. For number 4, solving for x, now we have a straight line. Okay, a straight line, as we know, is 180 degrees. So this has to be 180, and they've split it into 3 sections, one angle here, one angle here, and one angle here. We know 2 of the angles, but we're missing x. So we can write the equation 105 plus 62 plus x equals 180. And when we can combine these two, and that's going to give us 167 plus x equals 180. And now we're just going to do 180 minus the 167, and that will give us our x. So our x equals 13 degrees. For number 5, it's the exact same as the other one. We have a vertical straight line, but this still has to be 180 degrees, and we know 2 of the numbers, so we're going to do 52 plus 68 plus x has to equal 180 degrees, and we're going to go ahead and combine those, which is going to make that 6 and 6, 120 plus x equals 180 degrees. So 180 minus 120 equals x, and therefore x equals 60 degrees. Number 6 is a little more interesting. We've got that they equal 90, so some angle plus another angle equals 90 degrees. And then that A, one of the angles, has to be, I'm choosing A and B, you could choose whatever, has to be 2 times B, and so it gives you the 2-to-1 ratio, which of course if you added A and B, this could be A, this could be B, you end up with 3 as your total, and we want that total to be 90, right? So I'm going to do 90 divided by 3, and see that that's 30, and I'm going to do each of these times 30. Figure out why. Feel free to pause the video. So 2 to 1 to 3, in order to make it 90, was times 30. So 2 times 30 is 60, and 1 times 30 is 30. And there you have 2 angles that added together equal 90, and one of them is twice the amount of the other one. So number 7, last one. 2 angles have the sum of 180, and they're a 5-to-1 ratio. All right, so I'm going to skip right to the ratio. 5 to 1, and what would the total be? 6. We want that to be 180 degrees, so I do 180 divided by 6, and that's going to be 30. So again, I'm just multiplying by 30. I'm going to multiply by 30. 5 times 30 is 150. 1 times 30 is 30. So now I know my two angles added together to equal 180, where this one is 5 times the amount as this one, 150 and 30. Well, there you had it. If you have any questions, message me on Schoology, comment, and I'll get back to you. But hopefully this will help you see that knowing angles for right angles, acute, obtuse, and straight lines can help you find the missing values of angles, given that you know some piece of the puzzle. All right. Have a good day.